Hello, everyone. Welcome to the webinar on VizLab. Today, we are going to talk about this service, this tool for visualization, analysis, synthesis of Earth data. So we welcome you all here. We just let everybody enter just a couple of seconds so that everybody can log in and access the webinar. But I will take this time to introduce the speakers that we have today that will present the VizLab service, which is Massimo Cuomo and Francesco Garofalo from Exprivia, and Fabio Bellacanzone from the University of Trento. So we quickly can have a look at the agenda for today. So we'll have a brief introduction on the DestinE platform from Serco. And after that, we'll dive into what is VizLab, what does it offer. We'll also have the chance to look at a live demo. And after that, we'll have the opportunity to discover more about the testimonials. So actually a practical use case of how VizLab has been used to communicate El Niño-related insights. Having said this, so I just would like to remind you that this webinar is being, first of all, recorded. And after the webinar, we'll actually publish the recording, so it will be accessible on the DestinE Platform Learning Hub. Also, you have the chat that you can access here in the webinar, and we would like to ask you to introduce yourself to other participants, but also write your questions, because at the end of the webinar, we'll have a Q&A session, and we will be able to answer your questions together with our speakers today. And also, we'll have a very short feedback form that we will share with you at the end of the webinar, so you can share with us your insights and your thoughts about the webinar, but most importantly about the service. So before actually passing the floor and having an introduction on the DestinE platform, we also have a couple of introductory questions for you that we will share right now through a live survey that you should be able to see now. So we just ask you to take 1 minute, 2 minutes while our speakers get ready to answer them, so we can have a better understanding on how you use data visualization services and other things that can help us also to improve services for you in the future. So please just take this couple of minutes. See that some people are already answering. It is very important for us to obtain most insights from you. Also, if you have any technical issues, also don't forget, please, to write them in the chat so we can support you together. We have, together with speakers today, we have also other people that can monitor the chat and help you if there is any issue. See that already 10 people have answered, so incentivize all other attendees to actually, again, answer this couple of questions in just a couple of minutes to get the most out of this opportunity that we have today. All right. Thank you all. Thank you all for your answers. I will just keep it open for, again, a couple of minutes, but in the meantime, I will pass the floor to Barbara Scarda from Serco to give a brief introduction on the DestinE platform. Barbara, the floor is yours.
Hello, everyone. Just sharing the presentation. Okay, so good morning. First of all, thanks to Valeria for the introduction, and many thanks to all of you for joining this DestinE Platform Webinar. My name is Barbara Scarda, and I work for Serco. We are under a contract with the European Space Agency to implement and operate the platform together with an industrial consortium. So before handing over to the colleagues from partner Exprivia and the user who's been invited to talk about his experience with the service, I'll take just a few minutes to introduce the DestinE platform in the context. So the Destination Earth initiative of the European Commission is set to develop a digital replica of the Earth. And it has three core components, which are being developed by three entrusted entities. Now, the platform is one of these components, and it's implemented by the European Space Agency. It is, in fact, the entry point to DestinE. It's designed to provide access to an ecosystem of services that support evidence-based decision-making. It tackles global challenges, that is turning data into climate and environmental actions using advanced technologies. And it is built for a broad community that includes scientists, academia, but also policymakers and citizens, the general public. Now let's go quickly through the user journey on the platform, which depends on your user type. So the first step is for users to join the platform. And by joining, you can find general information. You can register following a standard process to access a number of selected services. You can find help under resources and contact us directly. And from resources, you can follow the links to the tutorials and webinars, which sit on the Learning Hub, and to the platform roadmap. A bit more in detail, you click on services and you can browse through the catalog of all the available applications and tools. Using the filter to find a service, you can use the filter, you can search by title or description, or by selecting the thematic area or the tags. There are various options for filtering. And on each service page, you will find the relevant documentation to use the application. On the Learning Hub that I mentioned, you can find a series of educational material that includes, for example, under training, the services video tutorials. In particular, you will find 2 video tutorials for VizLab, an overview of the main features and a more detailed step-by-step guide. And also the recording of this webinar will be published in the relevant webinars section. And on the Learning Hub, you will also find the demonstrators, some interactive tools that also include climate games and other resources. And I had also mentioned the platform roadmap. This is where you can find a list of recently released features, upcoming functionalities, and most importantly, ideas for improvement that are suggested by the user community. So this is part of our effort to stay transparent, make sure the platform evolves based on real user input. Now, once you've joined as an expert user, you're ready to engage with the platform's advanced services. Under the DestinE data portfolio in the About section, you can learn all about the DestinE digital twins, and also browse the list of services on the platform that provide access to DestinE data. And in order to use these services that enable you to download DestinE digital twin data, you need to apply for upgraded access. So after signing in, just go to your profile in Access Policy Upgrade and complete the form. Here you have the list of eligible categories. Another category of users on the DestinE platform are the contributors, therefore external service providers who wish to onboard their services on the platform for extended visibility, to join the community, and they also have the possibility to benefit from our cloud infrastructure. There is a dedicated section on the web portal where to find all the relevant information and the process in place for onboarding. And now concluding, we invite you to be part of the DestinE platform community based on your experience. Follow us on the web portal and on our LinkedIn page for the latest news and updates. And for the future, we will keep adding new services and new datasets with more and more innovative features and capabilities with the aim to keep developing the ecosystem. So that wraps it up. If you have any questions, feel free to ask now in the chat or get in touch later by the contact us form. And I'll hand it over to Massimo from Exprivia. Thank you.
Hello, everybody. Start by sharing my screen, I hope. Okay. I am Massimo Cuomo. I'm from Exprivia. I'm the project manager of the project VizLab. I will go through a very short introduction that just give an idea of all the functionalities of VizLab, and then my colleague Francesco will go deep into how to obtain those kind of visualizations, and finally there will be our testimonial, Fabio, that will show a practical use case of VizLab. So let's start. And okay, so what is VizLab? VizLab is an advanced web application that allows interactive geospatial data visualization that on the globe, so in 3D, so there is a possibility of putting data on the Earth, and also to have time analysis, so animations of seeing data that go through time. Which are the main functions? It's an application that is integrated into the DestinE platform because it allows to build scenarios with data from other services, take data that come from other services and put together. That's why in the title there was not only analysis but also synthesis, the possibility of data fusion. So these scenarios, we call them vids, of course, because it's VizLab, and there is a possibility of combining data on the globe and in time, and each vids can contain different scenes in which you can combine data layers, but also annotations on the globe or on overlay on the screen. User can mix not only data from other services of the platform, but also mixing in uploading their own data. So to mix data and to show to get the maximum from mixing their own data with, for example, climate DT, forecast, and so on, that are all the data that are available on the platform. Later on, we will see which data are available now and which are in evolution. And of course, scenarios can be saved and shared with other users, so allowing different use cases just to have some kind of presentations, lessons, whatever. We will see several cases later on. So the strength of VizLab, of course, is visualizations. So let's dive into the different visualization that we allow. Of course, we have maps, like everyone. We have maps that are images, basically, that we can put on the surface of the Earth. But of course, there are several different kind of maps that can be shown. WMS, that probably most of you know already, that are multi-resolution images. So when you move, you can go and see more detail zooming in. This is very suitable for high resolution data, but of course, if you want to have a time sequence, if it is not fast enough, as it appears in tiles, it sometimes can be confusing, and you have to stop to go slowly to see time evolution. Of course, there are images, but there are also videos that are the opposite in a way of WMS. So you can see very, very quick, because it's compressed, very, very quick variations, and maybe the resolution can be lower than WMS depending from your connection. we have another way of showing things that we call grid that allows to have on the in the application data that are numerical data, so they are very highly customizable. They can be you can change the color table, you can change the extension minimum and max, so you can compare different data sets because you can how can I say normalize them to given intervals. So in this way, you can have comparable data. But with grid, you can also have some more compelling visualization because you have the numbers. So you, if you want to show these things to people that are not very used to see color maps and associate them to values, you can do histograms that is a change in height that can be added to the colors. Other way of visualizations are flows, for example, like wind, ocean currents, and so on. We have two ways of showing very customizable way of showing flows, that is with animated streamlines and also vector fields that we call arrows that can be customized with colors and density and so on. We have also the possibility of showing multi-layer data for volume, and Francesco will show you how can be the interaction. It's not only the visualization for the data, but also very important is the interaction you can have with the data in order to select the area of interest and pinpoint the phenomena you want to show, you want to analyze, or you want to communicate. Then we have also the possibility of showing measurements that can be done by, for example, by sensors on the ground, and you have values that changes in time, but also the possibility of having satellite along track measurements. At the moment, we use them in the user has to upload his own data with this type of things, but it will be interfaced with more services. But this is a kind of visualization. Finally, we have the possibility of dynamic plots in which we can choose an area or a point or several points on the surface with some data and having a dynamic diagram plot in order to better analyze the numbers that are behind the pretty picture, let's say. There are basically two roles of VizLab users. One that can build things, and another role that can just view things. Of course, a logged in user, a registered user to the platform, can use resources on the platform to extract data, to save scenarios and so on, can extract what we call data cubes, because for example, some data are too large to be shown all at once. So you have to extract with no code, just by the application. You can select your area of interest, your time span, and VizLab extract for you. But this can be done only by logged in user. While if you are a guest, you can, of course, view what you have all the data available in the data offered, all the data that we call them ready for visualization, and all the already extracted data cube, and of course the scenarios that have been created. This allows the possibility of enlarging the type of user, because, for example, a teacher can or a scientist can be a logged in user, but can show its results or lessons or whatever to even no logged people. So the possibility of using VizLab and to enlarge the DESP users platform is very well exploited with this these kind of roles. Let's finish with what is the data offer that we have in VizLab. We access to several services that you see on the left. Climate digital twin data are one of the most important data sources, and also ERA5. We are extended to Copernicus and extreme weather digital twin. At the moment, we take data from Eden that gives access to WMS, and so space optimized data, then to DestinE Streamer that gives time optimized data that can be shown as videos. Then there is CacheB that is contain climate DT and ERA5 at full resolution. So it is the kind of data that is very large, so cannot be visualized all at once. So it's customizable, but has to be extracted. And that can be done on demand from the VizLab front end with absolutely no code. The VizLab can take care of doing this operation for the user. Of course, there is the possibility to upload users' data, and also a very practical external WMS adding, because many data are available around the world, let's say, in WMS format. So this can be added very easily. Of course, we have future development to enlarge the number of services and data, and also enlarge the possibility of interacting and visualization and visualizing data, and also the possibility of embedding. This can be very useful because we plan to have a version of VizLab that is embeddable into web applications and Jupyter notebooks. This will allow other services into the platform, but also outside, to embed VizLab, so having an advanced visualization that can be used with their own data, but into the platform, but also outside. So if someone has an application that is outside the DestinE platform, including VizLab, it will gain access to this platform. So is another way of enlarging the possibilities of having other users to access the platform. That's all for now. I hope I didn't go too much, but I can, of course, we are open to question and at the end. So I leave the room to my colleague Francesco that will guide you through the application. He will go through a new version of the application that will be deployed in the next days. We are having just some little delay. We would have liked to have already deployed for today, but for next week, we are pretty sure we will deploy. And so Francesco will show those kind of new application. Please.
Thank you, Massimo. Now you can see my screen, I guess. Okay.
Yeah.
Okay. Hello, everyone. I'm Francesco, one of the developers and engineers working on VizLab. In this part of the webinar, we will dive into an interactive demo of VizLab, exploring its feature and full potential. Let's start with the left-hand panel. We have some buttons that allows you to create a new viz, open a new one, save or publish. But what is a viz? Viz is a collection of interactive scenes. Each scene is composed by layers, and a layer is a data container that we will show data on the Earth. So the scene panel allows you to create a new scene, duplicate, or delete it. In this part of the panel, you can change the name of your viz, customize your description, or add specific categories about your viz. And obviously, the layers part that you can add or edit the layers. And the center canvas, in the center, we have our interactive 3D globe. It's like our stage. And at the top, you can find some customization about a new panel that contains the overlays and objects that enhance your graphical experience about VizLab. And on top, you can search a location to positioning on a specific location. Or we have also, I like to say, it's our no panic button. Just press on and you can restore your position if you are in trouble moving around the Earth. And at the right panel, we have some other customization about your scene. You can change the base map, the date, the position about your scene, and something like that. But last but not least, the timeline. So if you want to move around your data, your data, you can use our timeline. The timeline allows you to moving around data. And if you want, you can go just one step forward or one step backward, or you can play your data and see how data changes during time. Now, let's focus on layers. Layers are the data containers, and to add the layer, we must explore the VizLab data offer. To do this, just press on plus button right here and explore our data. VizLab supports data from multiple destination Earth platform services. We have WMS from Eden, ZAR from CacheB, and video from DestinE Streamer. Some formats like WMS and video are instantly ready for visualization, whereas ZAR data from CacheB requires some pre-processing before it can be ready for visualization. Regarding my data, VizLab allows user to upload video, images, TIFF, and measurement data as CSV. Additionally, we support also external WMS integration. Just insert your WMS URL, layer name, and then you can show on 3D Earth, like this. Now let's focus on visualization. Let's start with WMS. With WMS layer, we have not so much customization, just the opacity we can change, and we can move around data with timeline. Something different with TIFF and data from CacheB, because this kind of data is highly flexible. We can visualize with a standard 2D map on the globe, like this, and we can perform some customization according to our available color palettes, the opacity too. And we have another important feature. For example, if you have the same variables, but with two different datasets that has different minimum and maximum values, like these two layers, how you can normalize your data? With selecting a custom range. For example, just click on right here on custom range, you can normalize the minimum and maximum value and visualize the data with normalized value. But this kind of data, you cannot only visualize this kind of data, such as 2D maps, because you can change visualization type to histogram. Histograms is a way to visualize data as a 3D bars, like this. With histograms, we have much more customizable elements. You can change the resolution. It's like a tricky to have more 3D bars, or less if you want. You can change the vertical scale and the distance from camera. And you can select a precise area, just clicking on area clipping, and select a single part of the area that you are interested in, like this. And obviously you can change the color palette also for this kind of layer, and choose also one uniform color for every 3D bars. But you can also upload your own TIFF on VizLab with this simple model. Select data from your device, and then you can upload and visualize if you want as a 2D maps or as an histograms. But VizLab supports also the video play. So if you have some video, or if you want to see the video from DestinE Streamer platform, you just add layer as a video and then press play and visualize how data change in a smooth way during time. Another kind of layer that we support is measurement layer. It's very useful, for example, for ground sensor or long-track satellite measurement. And you can visualize this data, or if you want, on a full range data, like this. Just the current timestamp, and you can move around time to change timestamp, or a cumulative way from the beginning to the current time of a layer. You can visualize this kind of data as a 3D bar, like this. No panic button. Okay. And you can change the vertical scale too. But for example, if you want to visualize flow data, for example, you have the U and V wind components, you can use streamlines layer. For this kind of layer, you can change obviously the color palette and choose appropriate color palette according to what you want to visualize. And you can customize the visualization wherever you want. We have a lot of settings that you can personalize. But if you don't want to visualize the animated streams, but you are only interested to the data, for example, you can change visualization to arrows. The U and V wind component are visualized as a vector arrows. And obviously for this kind of layer, you can change the color palette or choose a single color, just like this. Or you can both visualize both layers. So in this layer, we have arrows and streamlines too. Now let's focus on our last type of layer, the volumetric layer. So VizLab supports volumetric rendering, so you can visualize your volumetric data inside VizLab. And you can perform some customization. You can change the value or clip your volume like this. And change color palette too, or use some other visualization. And you can also play the visualization and see how data change during times. Okay. But VizLab is not only visualization. For example, if you have two datasets that you want to compare, or maybe the same dataset, but at different time, in VizLab you can just apply a temporal offset at one of your data, like this. And then you can compare both layers, but one is 2020 and one is 2025 at your right, like this. But VizLab allows you to add some 2D elements, such as text, image, or video. And you can customize your visualization. But you can add also a color palette, about a specific layer, and visualize some 2D elements on the panel. Other nice elements is a plot. For example, if you want to visualize how data change during time for a specific layer, you can create a new plot. Select a specific area, a specific point, or a custom area, like this. And then moving on our timeline, and see how data change in our 3D bars, in 2D bars. Okay, and then you can save these bars on your PC, just clicking on Save. VizLab supports also 3D object on the Earth. You can add some landmark if you want to enhance some points, and you can customize the name of the landmark, marker image, or color. And you can add also image on 3D Earth. For example, if you have some area that you are interested to analyze, just click here and you can add image on the Earth. And this is VizLab. But we saw VizLab right here as a visualization tool. You can customize layer, but you can also present these bits. You can save and you can share with everybody. Just click on publish and you can publish to everybody. But you can also present these bits. Just clicking on, just choose a slide, click on present, then press play and visualize how data change during time in a more immersive way. So I can move during my slides in this kind of presentation mode. So, thank you very much. Now I'll pass the floor to my colleague Fabio, who will illustrate a real-world use case on VizLab application and its possible use case. Thank you. I stopped my share. Fabio, I think your microphone is off.
Thank you very much, Francesco. Okay, I'm ready to start and share the screen. Okay, hopefully you can already see my screen. And let's start with a simple question. Why should we care about a patch of warm water far away in the ocean? This question can even feel abstract, yet similar distant ocean signal can be one of the clearest ways to see that the Earth system is connected across very large distances. This distant ocean is the tropical Pacific, and the signal is El Niño Southern Oscillation, ENSO. When the state of the tropical Pacific changes, the signal can travel through the atmosphere and reshape risk far from the equator. It can alter the odds of rainfall, drought, agricultural impacts, seasonal circulation patterns, and so much more across several regions. In this story, I'll use El Niño as a compact example. I will first explain the mechanisms, then compare opposite tensor phases and revisit the famous 1997-98 event. Later, I will take you through a quick geographical tour of impacts, look at current monitoring and forecast uncertainty, and finally present a few use cases. So, before we discuss El Niño, we need a reference state. In the neutral tropical Pacific, warm surface water tends to accumulate to the west, while cooler water reaches the surface in the east through upwelling. This east-west contrast is important because deep tropical rainfall tends to organize over the warmest water. The ocean pattern, therefore, gives us a first clue about where the atmosphere will respond more strongly. Here, when I say convection, I mean the rising motion of warm and moist air. In the tropics, this rising air can build deep clouds and heavy rainfall. So where the warmest water sits, the strongest rainfall often tends to sit as well. This is the reference picture to keep in mind. Warm pool to the west, cold tongue to the east, trade winds holding this gradient in place. Mechanistically, the trade winds help maintain this state. In simplified terms, they blow from east to west across the equatorial Pacific, pushing surface water toward the Western Pacific and supporting cooler upwelling in the east. The ocean and atmosphere therefore act as a coupled system. The winds shape the surface ocean, and the surface ocean helps organize convection, rainfall, and winds above it. Okay, let's see if okay, the upload is a bit slow, but I think it's mostly because of my internet in this case. For monitoring ANSO, there are quite a lot of indices. An ANSO index is useful, but compresses the geography into one single number. Here we can keep the geography visible, and this is why the spatial views help. Once we know where the warm water is, we can then ask where convection is likely to move and how the winds will respond. And now just a few nice visualization from different angles. Okay, this is tilted the other way around. Now let's compare the two opposite coupled states, El Niño and La Niña. During La Niña, which is represented on the right, the normal gradient is often strengthened. So the Eastern Pacific is cooler and the east-west contrast is sharper, and the trade winds are stronger. I think you can see both things, right? During El Niño, the gradient weakens, warm water extends farther into the central and eastern equatorial Pacific. This is where the compare tool is useful. So I can keep two dates, two layers, and one geographic frame aligned. So ANSO becomes easier to explain as a direct, simple contrast. If you want to know, by the way, more about El Niño, I recommend watching the link YouTube video because it's very clear and very cool explanation. By the way, this presentation is already publicly available, so you can enter the VizLab platform and watch it later if you like, and then come back to the data layers and play a little bit with VizLab. Let's move. Okay. Here I simplify the comparison and focus only on sea surface temperature. On the La Niña side, the Eastern Pacific is cooler and the warm pool remains more confined towards the west. On the Niño side, warm water extends farther into the central and eastern equatorial Pacific. This is the first half of the story. The ocean surface has changed its geography. So the warmest water and therefore the preferred region for tropical convection, so precipitation, has shifted. In the next slide, I remove the SST layer and instead add back the winds. This makes the coupled nature of events easier to see. During La Niña, the westward trades are stronger. El Niño, instead, the wind field tends to weaken, and the ocean is so less strongly pushed towards the Western Pacific. In simple terms, the loop is this. Warm water helps move convection, then convection changes the wind, and the change winds can move the warm water. This is one reason ENSO can become self-reinforcing. Let's say we have an initial small shift in the ocean. This then can reorganize tropical rainfall, and this atmospheric response can then help the ocean shift farther away from neutral conditions. Okay, now we move from the general mechanisms to a specific historical case, the very famous 1997-98 El Niño event. This is one of the strongest and most studied El Niño events in the whole modern observing period. The numbers explain why this event became such a reference. By some estimate, it caused about 23,000 deaths worldwide and around 33 billion US dollars in damage. As we can see from this map, which is about sea surface temperature anomaly, not absolute temperature anymore, the anomaly is large, is coherent, and span the whole basin. The warm signal extends across much of the central and eastern equatorial Pacific. At this scale, the tropical signal becomes large enough to modify rainfall and atmospheric circulation very far from the source, so from the Pacific. Okay, here I switch the variable, but I keep the same event. Sea surface height anomaly gives us a second view of the ocean reorganization. In simple terms, warmer water tend to expand, and changes in wind and ocean circulation can also move a little bit the water table across the basin. Okay, yeah. Well, here I have two layers, but I cannot show them all together. So I have also the low-level wind, which has the vectors, and the upper level circulation. And again, the sea surface temperature anomaly maps. So this is a practical part of the workflow because VizLab lets me bring in my own scientific diagnostics because I have computed these wind anomalies, sea surface temperature anomaly on my PC, and they are useful when the built-in catalog is not enough. Anyone who has tried to make a custom climate map in Python or any other language programming knows that making it correct is one job, making it beautiful is another job. And here, much of that visual work becomes just a few clicks. Going back to the story, the warm anomaly again, span the whole basin. Wind anomaly that we have seen indicated that the atmosphere is clearly responding to the ocean state. And scientifically, as a concluding remark about this event mattered because it was observed during the modern tropical Pacific observing era. And so became a sort of stress test for the monitoring network and a reference for seasonal forecast systems. We are now moving away from the Pacific source to have a quick geographical tour of the El Niño impacts. Let's start from Southern Africa, where El Niño tends often to shift the rainy season toward more dry conditions. Here I simply connected VizLab to an external WMS showing a rainfall probability map for the El Niño impacts during December, January, and February, boreal wind. In brown, we have is showing us less rainfall than normal, once that green shows increased precipitation. Then we move to South America, and here the sign of the rainfall response is different. So in parts of southeastern South America, El Niño summers, because we are in the southern hemisphere, often lean weather. So the same Pacific forcing can raise drought concern in one region and flood concerns in another. And then again, if we move to the western Pacific side, Indonesia and northern Australia often face higher odds of drier wet season condition because of the shift of the equatorial convection towards the east. And finally, for what concerns the impact, El Niño also can influence the Atlantic hurricane season. The common pathway is that it creates an enhanced upper level wind jet over the tropical Atlantic, and this creates a stronger vertical wind shear that in turn can make the basin less favorable for storm organization. Okay, so far we have only reconstructed the past and explained the mechanisms. Now let's have a quick look at what is happening right now and what could happen next. For current monitoring, here I'm using a WMS layer rather than using the built-in ERA5 data. Reanalyses are very useful, but typically they lag a few days behind real time. Instead here, this sea surface temperature layer anomaly from the GHR SST is better for this near real-time role because it's high resolution, it's based on satellite and available on a daily basis with a minimum time latency. As of the latest official information, the Pacific right now is in ENSO neutral conditions, but with an El Nino watch, and we are already seeing some warm patches of water emerging close to Ecuador and Peru. And then I want to move to the seasonal outlooks. We have the IRI plume, which is already pointing toward an El Nino development. In the April update, because the May update is not yet available, El Nino conditions dominate already from April, May, June, and they remain strongly favored through the forecast period. At the same time, their official language is still careful. It says that in the upcoming boreal winter, we could range from ENSO neutral to a very strong El Nino. And the very strong outcome depends mostly on the wind evolution through the upcoming summer. On the other hand, the layer shown here is from the latest European Center seasonal forecast and is more aggressive. Is showing that by September 2026, we can have much stronger positive sea surface temperature anomalies. And I think they are both useful for communication. The key point is that different forecast products can agree on the direction, but disagree on the amplitude. The uncertainty should stay visible because it's a vital part of the forecast information. And as you can see, I can mix different sources, current observations, uploaded forecast layers, external services, and they all appear in one coherent spatial narrative. Now, to conclude, I'm moving.
Scusa Fabio, fai un po' veloce perché purtroppo siamo andati un po' lunghi. Quindi se
Yeah,
poi
I was just
sorry,
saying that
I am asking to go through the end because so we have some 5 minutes to question and answer. I'm sorry.
Thank you very much to remind me, but I am already in the very last part. So I'm moving away from the science to the user story. Because these ENSO material can be adapted for different audience. In this first example, I can use it for a poster, a scientific poster, and for this poster, I'm focusing on ENSO diversity, which is a very concrete example for me because I used actually this visualization a couple of days ago for my EGU poster. And for that poster, this view supported a precise comparison between two El Niño flavors, Central Pacific pattern and an Eastern Pacific pattern. Just a quick comparison, how they change. In simple terms, different El Niño flavors eat different parts of the tropical Pacific, and this can shift where the atmosphere is more strongly forced, where Rossby waves are launched, and therefore which remote regions are most likely to feel the impact. For a scientist, I think that this VizLab compare tool is meaningful because the setup is controlled, we have the same season, same variable, same settings, everything the same, and the resulting visualization is easier to discuss with someone standing in front of it. I think I'll skip the public risk briefing and jump right into the classroom example, which is the last one. So I can also use VizLab for a classroom setting. Here we can begin with physical intuition. Imagine that the Pacific is a very large bathtub. Trade winds and are represented by a fan. If the fan pushes the surface long enough, warm water piles up on one side. This metaphor is simple, but gives students a first mental model before turning to the real ocean. So here, the scientific layer is no longer the main character, but even a simple image asset can do part of the teaching. And in the last slide, we are changing the push. Wind weakens, the fan is off, and warm water can move back towards the east. And this is the bridge back to El Niño. So the real ocean atmosphere system, of course, is more complex than a bathtub, but still the metaphor makes the mechanism visible. And finally, I want to say that from my perspective, the most useful part is the continuity. We can move from a scientific comparison to a risk briefing to a classroom metaphor without changing the underlying physical story. And this makes VizLab a flexible communication space for different audiences. I'm done. Thank you.
Thank you very much, Fabio. If you're okay, I can go through the question that David has summarized.
Massimo, yes. One second. Just
yes.
Before you answer the question, just to announce that we also have a final, very quick surveys just to be launched. So you can all share your feedback and insights. And in the meantime, while you're answering to the survey, yes, Massimo, I kindly ask you to maybe answer some of the questions that our participants put in the chat regarding the technical software stack, for example, for the front-end visualization. So what is used for the 3D viewer, and also the other questions, if you have the time.
I can do it very quickly. So I can start, or you, while they are making the survey, or you prefer?
No, I will just keep the survey. It's already open, okay. So please, everybody answer. But in the meantime, yes, Massimo, if you can already answer some of the questions.
First question: the technical software stack is okay. Basically is cesium on the base, but all the visualization are custom made. So we take control of everything. The WMS is standard, but we access to the mechanism of cesium that also this brings us to the third question. That yes, we are at the end of the month we will support also WCS. At the moment we are focusing on Eden service WCS, but we are open to talk about other formats with other customers. So VizLab is still in evolution. So we are really eager to get user needs. Because we can go in one direction or another. This is one thing that is very useful to everyone, because also ESA and Serco are open to change. It's not like everything is blocked in a evolution roadmap that cannot be changed. Especially from if we get users advice, user requests, we can change our direction and insert functionalities that can be useful to users. So this is to answer 1 and 3. The answer to the 2 is no. At the moment, we don't get cartographic projection, only lat-long, and so normal 2D plots without the globe. No, I don't understand very well this. If we have to discuss outside this one, we can talk what is it. But VizLab is mainly focused on data fusion and to have everything on the 3D globe and having the mixing of everything from 2D and 3D, but especially 3D plus time is the focus of VizLab. Regarding the color maps, not at the moment, but we are in our roadmap. We need to include it because we have had a request also from other users. So we can add color maps. The question is, I'm looking at the question. I hope everyone is looking also at the chat. So when I say question 1 and 2 or 3, they understand what I'm doing. But question 4 is create normal 2D plots. Probably not at the moment, but custom color maps is in the roadmap. So we can use scientific accurate, whatever the user has. We load the data as you have seen in a numeric format. We can change and include other color maps. Marcus Netler, that maybe remembers me from an old contribution to other softwares. Ask if which are the user data formats supported. It's at the moment is basically images or TIFF files for surfaces, CSV for point measurement and so on. But everything is on in the documentation that you can find on the website of Destination Earth and VizLab. We plan in a near future to put to have the possibility to include also other formats. So if you have any specific requests, please write to us and we will be happy to add them. Regarding the API that one can automatically, and the sixth question is, does VizLab has an API that one can automatically insert and visualize on data sources? On data sources, as we have seen in this format, is already available. But we, as I told in my presentation, we are in the roadmap. There is the possibility of embedding VizLab in Jupyter notebooks or and in web applications. So there will be an API to connect the Jupyter notebook or the variables available on in JavaScript, TypeScript on the website to inject them into the visualizer that will be like a window into the. So if you have specific requests, again, we are really open to every. So you can write Barbara, or I don't know if our emails are seen somewhere here, but please feel free to contact Barbara, and she will be getting contact with us. All the mechanism of DestinE is in this way. If there are users that have specific requests, they can do it or through the platform, or if you want directly to us, we are very happy to comply with and to answer to everyone. Okay, there is all the question for at the moment. So I hope if there are any. Thank you, Barbara, for sharing all the links. So we are a little late, but not so much, I hope.
Okay, just 5 minutes late. Thank you, Massimo, and thank you to Francesco and Fabio for all the insight and the very insightful, engaging presentations that you gave today. Yes, I think Barbara just shared the link where you can contact the DestinE Platform. And also I'm resharing the previous message from Barbara is where you can get also information about the new version of VizLab, which will be announced soon. So just a quick reminder before we close that the recording of the webinar will be published on DestinE Platform Learning Hub. And keep yourself updated on the DestinE Platform insights and updates on the website. There will be more announcements in the future and webinars and events. Thank you both to participants and all the attendees today.
Thank you very much to everybody.
Thank you.
Thank you.